Okay, these examples are for the second translation theorem. And I'm going to first do number 40. Number 40, I see the u that appears there, and quickly I realize this has to be second translation theorem. So this function that I see here, this has to be f of t minus 1. Since I see that it's t minus 1, and these two have to be the same. However, I don't see t minus 1 explicitly anywhere, so what I'm going to do is I'm going to write it up. I'm going to replace t minus 1 for t, but I can only do that if I'm using an equal sign, so these two things have to be the same. Well, when I multiply this through, I would have 3t minus 3. Well, those two are not the same unless I add 4. And then I have 3t minus 3 plus 4 gives me 3t plus 1. So these two are the same, it's just that I can see the t minus 1 more explicitly there. And then that allows me to see that f at t then must be 3t plus 4. So that I can find f of s to be the Laplace transform of f of t. And that gives me 3 over s squared plus 4 over s. And so now I can use this formula here. I get e, a is 1, so e to the minus s. And then f of s, which is 3 over s squared plus 4s. Okay, now we move to the second one here. Again, now I see that I have an exponential function as a function of s, so I know that I should be using the second translation theorem. And in order to use it, I have to find out, you see, I have f of s, that's a Laplace transform of some function f of t. I have to find what f of t is, and then shift it by a. So I notice here that a is 2, and then my f of s is exactly 1 over s squared times s minus 1. Well, I need to find the Laplace transform, the inverse Laplace transform of this fraction here, and to do that I'm going to have to use partial fractions. So I know that I can rewrite this in this way. Some constant over s plus another constant over s squared, and then another constant over s minus 1. If I do this, I get 1 is equal to a times s minus 1 plus b times s minus 1 plus c times s squared. Or 1 is equal to, and I'm going to combine like terms. If I have s squared, I have a times it, that comes from this first term here, and then I have c. And then I have s times, I'm going to get a minus a from this first term here. And then I'm going to have a b that comes from here. And that's it. And then I have 1 times, there are no constants here. I get a minus b, and that's it. Okay, so the constant here, b, or minus b, needs to be equal to 1, so that b is negative 1. And then I have that minus a plus b has to be 0, and so that a is equal to b. So a is exactly minus 1 also. And then a plus c has to be 0. And so then c is exactly 1. So that means then that f of t is the inverse Laplace transform of f of s. And I'm going to rewrite this using these partial fractions that I found. So minus 1 over s minus 1 over s squared plus 1 over s minus 1. And this gives me minus 1 minus t plus e to the t. So now I can use the theorem and write here f of t minus a, well, f of t minus 2. This is minus 1 minus t minus 2 plus e to the t minus 2 all times u to the t minus 2. And this is my result.